Okay, so now you've had a go at answering the 10 questions underneath the worked examples. I'll just go through the answers very, very quickly with you. If you have any questions, email me or give me a call on Teams. I'll be available during our lesson on Friday. So with these ones, if you have a quick look through the questions to start with, we actually have, we're going to be using 3 of our mole formulas to solve these questions. So we've got the number of moles is equal to the number of particles divided by Avogadro's number, which is 6.02 times 10 to the 23. We're using our molar volume one, and we're using our moles equals mass over mole mass. So we're focusing on volume of gases, and we're focusing on solids. So question 1, how many moles of molecules are contained? Don't be confused by that. The question is still asking for how many moles there are. So you're still using the moles equals volume over molar volume. Don't forget your significant figures. The answer is 3.45 moles of neon. Looking at question 2, what is the volume of 0.8 moles of chlorine gas at standard laboratory conditions? The answer is 19.6 litres, but remember our significant figures. Because we are multiplying, we are going to go with the least number of significant figures. So that is not 2, like I have there. That was very silly of me. So let me do that again. So to get that to 1 significant figure, we need to convert that to scientific notation. So 19 litres becomes 2 times 10 to the 1 litre of chlorine gas. My apologies for that. I don't know what I was thinking. Question 3, how many molecules, so this is where we're using our Avogadro's number, are contained in 16.8 litres of xenon, and notice it's at standard laboratory conditions. So we're using 24.5 litres for our molar volume. You can see once you've found the number of moles, you times that by Avogadro's number, and you get 4.13 times 10 to the 23 molecules of xenon. Question 4, how many moles of molecules are contained in 39 litres? So that's one of our standard ones. Keeping our significant figures in mind, our answer is only going to be in 2 significant figures because that's the least that we have. So we have 1.7 mole of fluorine gas. Question 5, how many molecules are contained in 134.5 litres of oxygen at STP? Convert that volume to moles, multiply it by Avogadro's number, and we find out that there's 3.57, maybe that should be 10 to the 23 molecules of oxygen. Question 6, how many molecules of chlorine gas are in 23.7 grams of chlorine gas at SLC, so standard laboratory conditions? Now, take note of this. That doesn't mean anything for this question because we're given mass and we're asked to find the number of molecules. So we don't even need molar volume to solve this particular question. So find your number of moles given your mass first, and then calculate your number of molecules. And we have 2.01 times 10 to the 23 molecules of chlorine present in 23.7 grams of chlorine. Question 7 is another straightforward one. You've been given volume. It's at STP. So you find out that we have 7.40 moles of carbon dioxide gas. 8, bit of a different one. What is the mass of 40.34 times 10 to the 23 hydrogen molecules? So you've got to convert that first to the number of moles by dividing the molecules by Avogadro's number, and then you multiply that by the molar mass of hydrogen. So in that many molecules, we have 13.52 grams of hydrogen gas. Question 9, what is the mass? You're given the volume, so you need to calculate and convert to moles. Once you've got your moles, we're rearranging the formula, so mass is equal to moles times by molar mass. If you've forgotten how to calculate molar mass, don't forget, we're looking at the formula. So there is 1 nitrogen. We get this from the periodic table. This is the molar mass for nitrogen, and this is the molar mass of oxygen, and we add those two together. So coming back and having a look at our answer, because 3 significant figures is our lowest number in this calculation, I can't put it as 200 because 200 will only have 1 significant figure. So to keep this correct number of significant figures in the answer, you'll have to convert it to scientific notation. So that becomes 2.00 times 10 to the power of 2 grams of nitrogen dioxide. And this last one should say SLC. How many molecules are contained? We're given the volume. Because it's a SLC, we divide by 24.5, and then we multiply the number of moles by Avogadro's number, and we have 1.38 times 10 to the 22 molecules of hydrogen, and I've just noticed my mistake. It needs to be the 2 significant figures, so that's equal to 1.4 times 10 to the 23 molecules of hydrogen. Don't forget, if you've got any questions, shoot me an email or contact me via Teams. I'll be available all day. Yeah, just let me know. See ya.